Next, we're going to learn how to graph our tangent and cotangent functions. When we graphed sine and cosine, we just needed the multiples of pi over 2 to get a good idea of what the graph looks like. For our tangent and cotangent functions, that's not quite enough, so we're going to fill in a bit more of our table for these two functions. Starting with 0, because that makes a little bit more sense. Remember, tangent is sine over cosine. At 0, the coordinate is 1, 0. 0 divided by 1 is 0. At pi over 6, the coordinate is root 3 over 2, 1/2. When you do sine over cosine, you end up with 1 over the square root of 3, which rationalizes to root 3 over 3. At pi over 4, the coordinates are equal, so our tangent is 1. At pi over 3, the coordinates are backwards from where they are at pi over 6, and we get root 3 over 1, or square root of 3. Pi over 2, we're up at 0, 1, and 1 divided by 0 is undefined. That's where we'll have a vertical asymptote for our tangent function. Same values off to the left, but tangent will be negative. We'll plot these points to get our tangent function. Notice the way that I scaled the x-axis, they're not spaced evenly. Pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees, and pi over 2 is 90 degrees. So they are not spaced evenly. There's jumps of either 30 or 15 degrees between them. Scaling our y-axis, square root of 3 is just shy of 2. And then I'll sketch in my asymptotes, where my tangent function is undefined at pi over 2 and negative pi over 2. Plotting those points, 0, 0. Square root of 3 over 3 is about 0.6. Pi over 4, 1. And pi over 3 about 1.7. And then we get those same values off to the left, but they are negative. With how wide the x-axis is scaled, this is only, first of all, giving us one period of our tangent function, and it kind of looks like it's a line, but it actually ends up being more like a snake function because of those asymptotes. For our domain, x cannot equal odd multiples of pi over 2, so we could do pi n over 2 where n is odd, or we could do cannot equal pi over 2 plus pi n, which is where our vertical asymptotes do occur. The period from pi over 2 to pi is 1 pi, so this is different from our sine and cosine functions, and the range is all real numbers, which is also very different from our sine and cosine functions. Here's that same information for you along with the transformations, which work the same way as the sine and cosine, but you have to be very careful when you're setting up your period for the tangent as well as the phase shift, because the period of tangent is pi. That is different than for sine and cosine where it's 2 pi. Our tangent function starts at negative pi over 2 for one period, and it ends at pi over 2. So when we're finding those left and right asymptotes for the tangent function, we have to use those values instead. And again, finding the period, it would be pi over b, because the parent function has a period of pi. Cotangent is very similar, but it's the reciprocal of tangent. So if you can think of those tangent values we just went through, the reciprocal of 0 is undefined. The reciprocal of 1 over square root of 3 is square root of 3. The reciprocal of 1 is 1. The reciprocal of square root of 3 is root 3 over 3. And the reciprocal of undefined is 0. And then we get into the second quadrant, and those values are negative. Again, the scale for our x-axis is not spaced evenly. We get pi over 6, pi over 4, pi over 3, pi over 2, and then getting into the second quadrant, we have 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Plotting those vertical asymptotes where our cotangent function is undefined. And we'll scale our y-axis as 2 and negative 2 again. Plotting those points, pi over 6 root 3 is up at about 1.7. Pi over 4 is at 1. Pi over 3 is at about 0.6. Pi over 2 we're down to 0, and then those values go negative. Negative 0.6, negative 1, negative 1.73. Same shape as the tangent function, it ends up being a snake. For cotangent, our domain cannot equal multiples of pi, which means that's where our vertical asymptotes do occur. Period again is pi, just like the tangent function, and the range, same as the tangent function, all real numbers. Here's that information again put together for you. Couple of differences. Asymptotes occur at 0 and pi because those are the asymptotes of the parent function, but the period is the same as tangent, pi over b. And in the next video, we'll take a look at transformations of these two functions.